It feels like just yesterday, the promise of AI in software development felt like something out of science fiction. Now, it feels like every other day there's a new AI tool promising to revolutionize how we write code, how we test it, how we deploy it. And while that's incredibly exciting, this rapid explosion of innovation also brought, well, a bit of a Wild West situation right into our repositories. Suddenly, our code bases were filled with different instructions for different AI agents, and frankly, it was getting a little chaotic, adding friction instead of removing it.
Absolutely. What emerged wasn't just a minor inconvenience. It really created a truly fragmented landscape for anyone trying to seriously integrate AI into their development workflows. Imagine, if you will, a chaotic collection of vendor-specific configuration files, each with its own unique format and conventions. This led to a substantial and often redundant maintenance burden for development teams, and even more critically, it severely hindered any meaningful interoperability between all these powerful yet isolated tools. It became a real operational friction point that, paradoxically, slowed down the very innovation AI was meant to accelerate. It was a clear signal that the industry needed a common language.
Right. And this is where our story takes a truly fascinating turn. Faced with this burgeoning chaos, a coalition of industry leaders, recognizing the urgent need, stepped up. They worked together to create a simple, open, and predictable standard for telling these AI agents what to do, clearing up that chaos and building a common ground. That standard is called AGENTS.md.
It's more than just a new file. It's genuinely a game changer. This standard aims to unify how human developers collaborate with their AI counterparts, providing that much-needed common language for instructions that were previously siloed, incompatible, and frankly, a nightmare to manage. It's about bringing order to the machine-to-machine conversation within your codebase.
So today we're embarking on a deep dive into agents.md. We're going to unpack why it was so desperately needed, what it is at its core, how it works in practice, and, why it's rapidly becoming a foundational piece of infrastructure for the future of AI-assisted software engineering. So settle in, because this is a story of collaboration, standardization, and a clear path forward for intelligent coding. Okay, let's start by painting a vivid picture of the before. Before Agents.md, if you were an ambitious developer or a forward-thinking team trying to leverage AI to supercharge your efforts, you were probably juggling a truly bewildering array of different files. Can you describe what that looked like on the ground? What was the day-to-day reality?
Yeah, but before Agents.md, the landscape was, to put it mildly, quite a mess. As AI coding agents grew rapidly in capability and ambition, their creators quickly realized that these tools couldn't operate effectively in a vacuum. They absolutely needed in-repository context to function effectively within any given project. An agent couldn't just guess how to correctly build a complex project or run its tests or adhere to its specific coding style. So each individual AI tool vendor, whether we're talking about major players like Anthropic and Google, or foundational platforms like OpenAI, and even dedicated AI native editors like Cursor, independently recognized this critical need for rich in-repository context to guide their agents' behavior and ensure reliable outcomes. The why behind this proliferation was clear. AI agents need explicit instructions to understand a project's operational mechanics. But what turned out to be a chaotic explosion of disparate and incompatible instruction files. For instance, if you're deeply invested in using Anthropic's agent, you might find yourself creating and maintaining a Claude.md file. For Google's agent, you'd likely have a Gemini.md file sitting right alongside it. Cursor, a popular AI native code editor, opted for a .cursor rules directory structure to store specific guidance. And even OpenAI, in its earlier iterations, experimented with a codex.md file. What truly stands out here is that each of these files, despite their unique naming conventions and internal structures, serve the exact same fundamental purpose: to instruct an AI agent on how to properly build a project, run its tests, apply linting rules, and contribute effectively to the codebase. Yet they all utilized a unique, non-standardized format. It was as if everyone was trying to communicate the same essential message, but each speaking a different, mutually unintelligible dialect of the same core language. This made any aspiration of a unified AI workflow feel utterly out of reach.
So imagine you're a team lead, incredibly excited about the potential of AI to boost your team's productivity and accelerate development. You adopt these powerful new tools only to discover this chaotic landscape. What were some of the most immediate and painful consequences of this fragmented approach on their day-to-day operations and team productivity? It sounds like it could have easily added more work than it saved.
You're absolutely right, and for many teams it often did add significant overhead. One of the most glaring and frustrating pain points was the sheer redundancy and maintenance burden. Let's take a common scenario. If your project, for instance, used pnpm install as its command to set up dependencies, that critical instruction wasn't just written once. It had to be meticulously duplicated across your keyloggy.md, your gemini.md, and potentially any other vendor-specific instruction files you were using. Now imagine a seemingly simple change. Say you update your build process to include a new optimization flag, or you adjust a testing argument. This single minor change would then require you to update several of these files in lockstep. This exponentially increased the risk of inconsistencies and errors, making what should have been a straightforward update a potential minefield of forgotten files and subtle bugs that could break an agent's understanding of your project. It was a constant battle against desynchronization.
And beyond the sheer maintenance headache, I can only imagine what this meant for individual developers just trying to navigate their own projects. The original report mentions something the community affectionately, or perhaps exasperatedly, called cursed setups. What exactly did that mean for a developer trying to get their work done?
Cursed setups. That term truly captures the community's sentiment. Imagine opening the root directory of your repository, a space that should ideally contain high-level project files and documentation, only to find it cluttered with a dozen or more different agent-specific configuration files. Each file might be named slightly differently, have its own unique internal structure, and exist purely to serve one specific AI tool. To try and mitigate this overwhelming sprawl, developers often resorted to ingenious yet ultimately brittle workarounds. A common one was creating numerous symbolic links. They'd link all these proprietary files back to a single source of truth file, hoping to at least centralize the content, if not the format. But these symlink-laden structures were incredibly confusing to anyone new to the project, prone to breaking when paths changed, and ultimately a significant source of developer friction. It was an attempt to impose order on a chaotic system, but it often just added another perplexing layer of complexity, earning it that cursed moniker.
So, beyond the sheer annoyance and the development friction created by these cursed setups, what were the bigger, more strategic implications of this rampant fragmentation? It sounds like it could have had significant long-term consequences for the broader adoption of AI in coding, potentially stifling innovation.
Absolutely. The strategic implications were indeed profound and far-reaching. The proprietary nature of each instruction format inevitably led to significant information silos. A major challenge here was that an AI agent from Google simply couldn't read the instruction file meticulously crafted for Anthropic's agent, and vice versa. It was like two brilliant minds trying to collaborate on the same complex engineering problem, but speaking completely different operational languages within the same code base. This meant developers found it incredibly difficult to seamlessly switch between different AI tools, even if one was superior for a specific task. And even more critically, it made it nearly impossible to use them in concert for different stages of a task. You couldn't, for example, pick the best AI tool for generating boilerplate code, then feed its output to the best tool for writing comprehensive tests if they couldn't even share the fundamental project context. This effectively created a soft form of vendor lock-in, subtly discouraging experimentation and forcing teams to standardize on a single agent, even when different tools possess distinct strengths for different parts of the development workflow. This, as you rightly point out, severely stifled the potential for a truly dynamic and adaptive development workflow. And stepping back to connect this to the bigger picture of AI's promise, this fragmentation also gravely stifled multi-agent workflows. The true, groundbreaking promise of AI-assisted development isn't just one agent helping you, but an entire ecosystem of specialized agents collaborating intelligently. Imagine a sophisticated pipeline where one agent excels at generating boilerplate code, another is a master at writing comprehensive test suites for that code, and a third is an expert at analyzing security vulnerabilities or optimizing performance. Such an intelligent orchestration is only truly feasible if all these agents can operate from a shared, consistent, and unambiguous understanding of the project's context, its operational procedures, and its specific requirements. The fragmented landscape, with its incompatible instruction files, made achieving this shared context virtually impossible without significant, arduous manual intervention. This lack of a common ground was effectively throttling innovation in these advanced collaborative AI development methodologies, keeping us from unlocking the full potential of an AI-powered engineering team. What's truly insightful here is that this wasn't necessarily a result of poor design on anyone's part, nor was it malicious. It was, rather, a natural and almost inevitable consequence of a rapidly expanding and intensely competitive technology sector. Each company was innovating at breakneck speed, independently solving the immediate problem of how to provide vital in-repo context to their own agents. It was a classic Cambrian explosion of ideas and implementations, where numerous distinct solutions emerged simultaneously, all preceding a much-needed period of industry consolidation and standardization. The growing chorus of frustration from the developer community with this mess of redundant files became the indispensable catalyst, creating the necessary pressure for the industry to finally move towards a unified, collaborative solution.
That truly paints a vivid picture of the problem. But for a moment, let's look at how the landscape dramatically shifted with the arrival of Agents.md. Table 1 in our source material gives a fantastic summary. What are the key differences, the truly profound shifts that stand out when you compare the before and after of Agents.md?
Looking at that before and after from Table 1, the real insight here isn't just about having fewer files. It's about a fundamental power shift and a profound increase in efficiency. Previously, you were dealing with multiple, disparate vendor-specific files like Claude.md or Gemini.md, each a mini silo of instructions. Now with Agents.md, we see a consolidation into a single standardized file per project or subproject. The most impactful change is how interoperability transformed from being low or practically non-existent to high. This means any compliant agent, regardless of its vendor, can now read and understand the same instruction file, fostering true choice and enabling complex, multi-agent workflows.
Right, so one file to rule them all, basically.
Exactly. And furthermore, the maintenance burden, which was previously high due to the necessity of duplicating instructions across many files, has plummeted to low because you now have a single canonical source of truth. This radically reduces the risk of inconsistency and errors. The developer experience, which was often confusing and plagued by those cursed setups, has become clean, predictable, and significantly less frustrating. And perhaps most strategically, the ecosystem impact moved from subtly fostering vendor lock-in, where switching tools was a painful ordeal, to actively promoting a competitive, innovative market. Now, AI tools must differentiate themselves on superior model quality, reasoning capabilities, and speed, rather than simply on proprietary formats. This isn't just a step forward, it's a truly transformative insight for the industry, democratizing access to AI-driven development and accelerating innovation across the board.
Okay, we've painted a pretty vivid picture of the chaos that was prevalent. Now that we understand the scope of the problem, let's turn our attention to the ingenious way the industry began to tackle it. How did Agents.md emerge as the answer, finally cutting through all that proprietary clutter and offering a unified path forward?
Well, the collaborative solution for Agents.md truly was born out of that shared industry-wide frustration and a collective understanding that this fragmentation was holding everyone back. The core goal driving the creation of Agents.md was elegantly simple: to establish a simple, open format for guiding coding agents in a predictable and universally understandable way. The working group set out to define a dedicated and consistent location within any software repository where an AI agent could reliably find all the essential context and explicit instructions it needed to understand and work on that project effectively. It was about creating a shared language for a new kind of teammate. The key analogy here, and it's a remarkably powerful and intuitive one, is that Agents.md is to an AI agent what README.md is to a human developer. Think about this for a moment. A README.md is universally recognized as the primary entry point for a human contributor to any project. It offers a high-level overview, provides quick start guides, and outlines contribution guidelines in an accessible format. Agents.md is designed to serve precisely the same purpose, but for an AI agent. It's intended to be the very first file an AI agent consults, to grasp the operational mechanics, the etiquette, and the specific procedures of a codebase. This analogy beautifully underscores the standard's core objective: to elevate AI agents from mere automated tools to the status of collaborative integrated partners in the development process. It gives them a formal, universally understood onboarding document that codifies essential non-code instructions, such as how to set up the development environment, execute testing procedures, enforce coding standards, and even the precise format for submitting pull requests. This paradigm shift moves the interaction from simply issuing isolated commands to a tool to truly enabling a rich, ongoing collaboration with an AI teammate.
That's a fundamental principle, isn't it? The deliberate decision to keep human documentation separate from machine instructions. It sounds so incredibly obvious when you articulate it, yet in the scramble of new technology, it's a distinction that can so easily be overlooked.
It absolutely is a foundational principle, and it represents a highly deliberate design choice aimed at optimizing the experience for both distinct audiences. README is, and unequivocally should remain, optimized for humans. Its core purpose is to be the inviting front door of the project, offering a concise, high-level overview, quick start guides, and engaging human-readable descriptions that are easy for a person to digest and understand at a glance. It's about making a good first impression and providing human contributors with the most critical information they need to get oriented quickly.
Right. Keep the README clean and welcoming.
Exactly. AGENTS.md, on the other hand, is meticulously designed and optimized specifically for machines. This file is intended to house the detailed, explicit, and often verbose context that AI coding agents require to operate not just correctly, but reliably and consistently within a project. We're talking about highly precise build commands, specific flags for running tests, detailed linting rules, and critical security protocols, the kind of granular operational information that is absolutely vital for an AI agent to perform its tasks without error. This kind of information, while indispensable for an autonomous agent, would typically clutter a README.md file, making it less approachable and potentially confusing for human contributors who don't need that specific, deep level of operational detail in their initial project overview. By rigorously maintaining this strategic separation concerns, we achieve two significant benefits. We get focused, concise, and engaging README.md files for humans, dramatically improving their onboarding experience, and simultaneously provide an unambiguous, rich playbook specifically for AI agents, ensuring they receive precise guidance that effectively complements, rather than duplicates or conflicts with, existing human-centric documentation.
Makes perfect sense. So what are the guiding principles behind this standard?
Well, the working group behind AGENTS.md understood that for a standard to truly gain traction and become widely adopted, it needed clear, intuitive guiding principles. First among these is consistent location and naming. The standard mandates that AGENTS.md must be placed at the root of the repository or at the root of any relevant subproject within a larger codebase. This predictability is paramount. It means any compliant AI agent knows exactly where to look for instructions, eliminating guesswork, drastically simplifying tool integration, and ensuring reliable operation across diverse projects.
Okay, so always agents.md at the root. Symbol?
Simple and effective. Second is the principle of human and machine readability. The strategic choice of Markdown as the file format is absolutely key to this. Markdown is a lightweight, widely understood markup language that's incredibly easy for humans to author, read, and review using any standard text editor or within version control interfaces. Its simple, structured nature, relying on conventional headings, bullet points, and code blocks, also makes it remarkably straightforward for AI agents to parse and interpret without requiring complex, brittle, or proprietary parsing engines. It's the perfect bridge between human and machine comprehension.
Yeah, everyone knows Markdown.
Pretty much. And third, flexibility and extensibility. The standard intentionally avoids imposing a rigid formal schema, such as a strict XML or JSON schema definition. This flexibility was a crucial design decision for fostering widespread adoption because it empowers development teams to adapt the file to the diverse and ever-evolving needs of different programming languages, various frameworks, and unique project structures, whether it's a simple script or a massive monorepo. Developers can include precisely the sections and details most relevant to their specific workflow without being constrained by an overly strict, potentially limiting specification. These three principles collectively ensure that AGENTS.md is both powerful in its guidance and remarkably approachable in its implementation.
So at its heart, it's just a Markdown file. That seems almost deceptively simple, doesn't it? For such a critical standard, what makes that perceived simplicity its greatest strength rather than a potential limitation?
You've hit on a crucial point. What truly stands out here is that simplicity isn't just a feature. It's the critical foundational strength of AGENTS.md, not a limitation. The file is, by deliberate design, a plain Markdown file. This choice carries immense power because Markdown is, quite frankly, universally understood by virtually every developer and natively supported by almost all modern code editors, integrated development environments, IDEs, and version control platforms. This ubiquity immediately lowers the barrier to entry for creating, reading, and maintaining the file. If you can write a README.md, you can write an AGENT.md. It requires no new tools, no special plugins, and no steep learning curve.
Right, no complex schemas to learn.
Exactly. A truly crucial aspect of this simplicity is the deliberate omission of a formal specification or a rigid schema, the kind you might find with XML, YAML, or JSON schema. This design decision had an overwhelmingly direct and positive impact on its rapid adoption. By consciously avoiding a strict, machine-enforced structure, the standard empowers developers to create an agents.md file with the same ease and flexibility as they would a README. It ingeniously relies on conventional Markdown headings, like #tag setup commands or #tag testing instructions, to logically delineate sections. This approach is not only incredibly human-readable and authorable, but also straightforward for AI agents to parse and interpret programmatically. This informal but standardized approach mirrors the success of other widely adopted low-friction repository files like .gitignore for telling Git what files to ignore, or contributing.md for human contribution guidelines. These files thrive precisely because of their simplicity, their universal accessibility, and their minimal friction, qualities that agents.md masterfully leverages. It's an elegant solution to a complex problem, proving that often the simplest approach is the most effective.
All right, so if I'm a developer or a team lead creating one of these agents.md files for my project, what sections should I expect to see? What's the comprehensive playbook, the essential manual that our AI teammates need to effectively onboard and contribute to a new project?
A well-structured agents.md file typically functions as a comprehensive operational manual for an AI agent, covering all the critical aspects of a project. You'll generally start with a project overview. This is a brief, high-level summary of the project's architecture, its core purpose, and its technology stack. For example, it might state, this is a Next.js monorepo using PNPM workspaces for a customer-facing e-commerce platform. This helps the agent quickly orient itself and gain an initial understanding of the entire code base and its context.
Okay, just the basics to get oriented.
Exactly. Next, and this is absolutely crucial for any agent, you'll provide setup and build commands. This section is where you list the exact copy-pastable shell commands required to install all dependencies, configure the local environment, and build the project from scratch. Think PNPM install, PNPM dev, or NPM run build. Precision here is paramount. These commands ensure the agent can reliably set up a working development environment without having to guess or make assumptions, which are often sources of error.
Got it. No guesswork allowed.
None. Then comes testing instructions, which is arguably one of the most vital sections for ensuring agent reliability. It contains detailed procedures for running the project's entire test suite. This means specifying commands to run all tests, such as PNPM turbo-run test filter, project name for monorepos, as well as instructions for running specific, targeted tests, like PNPM vitest run NST test name. Providing these granular instructions empowers the AI agent to thoroughly validate its own changes, proactively catch regressions, and ensure the integrity of the code base, just as a human developer would.
Super important for automated changes.
Absolutely. You'll also want to include code style and linting information. This section clearly outlines the project's established coding conventions, stylistic preferences, and provides the commands to run static analysis and linting tools, for example, PNPM lint or NPM run format. This guidance is essential for the AI agent to generate code that is consistently aligned with the existing code base's style and quality standards, minimizing friction during code review.
Keeps the code looking consistent.
Precisely. For seamless integration into team workflows, there are pull request and commit guidelines. These are explicit instructions on how to format commit messages and pull request titles, following common patterns like project name title, descriptive of changes, or conventional commits. You might also include pre-commit checks to run, such as PNPM lint and PNPM test before committing. This ensures that the agent's contributions integrate smoothly into the project's version control history and adhere to established team conventions.
Okay, so how to play nice with the team's process.
You got it. Finally, a truly critical section for guiding any autonomous agent is security considerations. This area can include explicit rules and best practices about handling sensitive data, such as personally identifiable information, PII, how to manage API keys, and guidelines for network access. For instance, a rule might state, do not include PII and log output. All credentials must be loaded exclusively from environment variables. These are absolutely essential guardrails for a safe, responsible, and secure agent operation, proactively preventing potential data breaches or the accidental introduction of security flaws by an agent that might otherwise be unaware of these nuanced requirements. This section ensures the AI operates within the strict security perimeter of your project.
That's a comprehensive overview. Now, the source material points to the OpenAI agents.md repository as a canonical, living example of the standard in action. What does that particular example tell us about the standard's ambition? Is it purely for simple projects, or can it genuinely handle enterprise-level complexity and modern development paradigms?
Analyzing the OpenAI agents.md example truly highlights the standard's ambition and its profound suitability for complex modern software projects. It immediately dispels any notion that agents.md is just for simple scripts. Let's dig into some specifics from their sample agents.md file. Under dev environment ticks, you see commands like pnpm dlx turbo run, where project name, which is a sophisticated command to jump directly to a specific package within a monorepo, or pnpm install filter, project name for installing dependencies for a particular subproject, and even pnpm create vite at latest project name template React for spinning up new React projects using a modern toolchain. But these are far from trivial basic commands. They reflect the realities of managing large-scale multi-package repositories.
Okay, so it's using real-world complex commands.
Exactly. For testing instructions, it intelligently points to the project's continuous integration plan, typically located in .GitHub workflows, indicating a deeply integrated approach. It also provides specific commands like pnpm turbo run test filter project name for running tests on package-specific changes, and pnpm vitis run test name for executing highly targeted tests based on a specific test name. This level of detail empowers an agent to perform precise, efficient testing crucial in fast-moving development environments. And for PR instructions, it specifies a conventional title format like project name descriptive title and mandates running pnpm lint and pnpm test before committing, ensuring code quality and consistency from the very first interaction.
Interesting. And what about the tools mentioned? pnpm turbo, vita bait.
Yes. The explicit choice of tooling in this example is particularly revealing and significant. pnpm is a highly regarded, fast, and disk space efficient package manager, widely favored in large-scale projects and complex monorepos for its performance and consistency benefits. Turbo is a cutting-edge, high-performance build system specifically designed to optimize monorepo development by intelligently caching and parallelizing tasks, dramatically speeding up build and test cycles. Vite and Vitist are modern lightning-fast tools for building and testing web applications, offering the superior developer experience compared to older, often slower alternatives. This sophisticated selection of tools sends an incredibly clear signal. AGENTS.md is not just capable of handling the complexities of sophisticated enterprise-grade software projects, but it's designed to thrive within them. It is equipped to scale seamlessly with project complexity, integrate deeply into modern monorepo architectures, and become a central nervous system for even the most advanced development pipelines, positioning the standard as a robust, future-proof solution for cutting-edge development teams.
It's one thing to have a specification written down, a theoretical document, but it's an entirely different thing to see it vibrantly in action, a truly living example. The OpenAI agents.md GitHub repository isn't just a place to read about the standard, is it? It feels like it serves a much more profound purpose.
You're absolutely spot on. The OpenAI agents.md repository serves a crucial and remarkably effective dual purpose, demonstrating a deeper commitment to the standard's adoption. Firstly, it is indeed the canonical source of documentation. This is the official home where you'll find the definitive definition of the AGENTS.md standard, core examples that illustrate its usage, and all the community-facing information necessary for adoption. It acts as the single authoritative source of truth that developers, tool builders, and curious learners can reference when implementing or adopting AGENTS.md in their own projects.
Okay, so the official rulebook.
Right. But secondly, and equally important for its credibility and practical value, it functions as a living reference implementation. This repository contains the actual source code for the public-facing website, https://agents.md. This isn't merely a static page. It's a functional web application built using modern technologies. And crucially, the repository itself contains its own agents.md file. This is a classic and highly effective example of eating your own dog food. The creators of the standard are demonstrating its utility and adherence within their own project. This strategic choice allows developers to see not only a theoretical example of the standard, but also precisely how it is applied in a real-world, albeit focused, functional project. This dual approach signifies a much deeper commitment to the standard's stewardship and offers an incredibly rich, tangible learning experience that goes far beyond what a simple static document could provide. The active and ongoing maintenance of this repository, clearly visible through recent commits in its history, further signals a long-term investment in the standard's evolution and continued relevance in the fast-paced AI landscape.
And the repository itself, the one hosting the agents.md website, uses the standard. That's a great meta example. What kind of technologies are powering this living example? Does its tech stack truly align with what modern developers are using and expecting today, lending it even more credibility?
It absolutely does, and this choice of stack is a powerful statement in itself. An inspection of the repository's files and configurations reveals a thoroughly modern and highly relevant technical stack, which strongly reinforces the standard's alignment with current best practices in web development. The project is primarily built with Next.js, which is a widely adopted and incredibly popular React framework renowned for building server-rendered and statically generated web applications. You can clearly see this evidence by the presence of key configuration files like next.config.ts and next.env.ets within the repository.
Next.js, yeah, very common.
Very. The primary language used throughout the codebase is TypeScript, which is a statically typed superset of JavaScript. This is robustly indicated by the .ts and .tsx file extensions found across the codebase, the ubiquitous tsconfig.json file, and language statistics that confirm TypeScript comprises a substantial 94.4% of the repository's code. The pervasive use of TypeScript is a strong signal of a deep commitment to code quality, long-term maintainability, and type safety, all of which are paramount in professional, enterprise-grade software engineering and resonate strongly with modern development teams.
TypeScript, another sign of serious engineering.
Exactly. For efficient package management, the project leverages PNPM, a fast and disk space efficient package manager that's gaining significant traction, particularly in monorepos. Its use is confirmed by the presence of a pnpm-lock.yaml file. And for managing and transforming its CSS, the project employs PostCSS, a powerful tool that uses JavaScript plugins to automate and enhance styling workflows, evidenced by postcss.config.mjs. This deliberate selection of modern, widely adopted, and high-performance technologies makes the AGENTS.md standard immediately relatable and highly credible to professional software engineers. It eloquently demonstrates that AGENT.md isn't just a theoretical concept, it's built upon and designed for the cutting edge of development, proving its practical applicability in sophisticated environments.
And what about the other files in there, beyond the code itself?
Right, beyond the raw code and configurations, a few specific files in the repository stand out when we consider the standard itself. The repository's own agents.md file is perhaps the most direct and compelling endorsement of the standard, serving as a concrete, self-referential example for others to emulate within a real-world project. Then there's the README.md file, which contains the project's human-facing documentation, distinctly separate from the agent-facing agents.ssde. This clear separation powerfully reinforces the core principle of separation of concerns that we discussed earlier. Humans get concise overviews. Machines get precise instructions.
Reinforcing that key idea again.
The license file is also incredibly critical. The repository is licensed under the MIT license, which is an open, highly permissive, and widely accepted license. It explicitly encourages free use, modification, and distribution of the code, which unequivocally confirms the open and collaborative nature of the standard. This actively removes any potential legal or proprietary barriers to its widespread adoption, making it accessible to everyone. And of course, the pages, components, and styles directories contain the actual Next.js application code that powers the https.agents.md website itself. This makes the repository a self-contained, fully functional project that is simultaneously a specification, a working implementation, and a powerful demonstration. This complete, functional, and exceptionally well-structured repository, even benefiting from a premium domain name, establishes a robust foundation for the standard's legitimacy, credibility, and long-term viability. It's a much more impactful statement than a simple text document could ever be.
A standard, no matter how elegant or well-designed, is only as good as its adoption by the broader community. And for Agents.md, the convergence has been incredibly swift. Who are the big players, the key industry leaders who jumped on board, showing this isn't just a niche idea, but a truly collective industry movement?
What's truly remarkable here is that the Agent.md initiative is emphatically not an OpenAI-centric project, but a genuine, proactive, and widespread industry-wide collaboration. This broad coalition of support is absolutely crucial for its long-term success and sustainability. Key stakeholders include, of course, OpenAI, Codex, who play a central stewardship role and host the canonical repository, providing a strong anchor. Then you have Google with their Jules agent and Gemini CLI, whose early and enthusiastic participation and support were critical for establishing broad industry consensus and proving its cross-vendor viability. Anthropic, another major and highly influential player in the large language model space, also committed to supporting Agents.md, which was instrumental in solidifying the industry's move away from their own vendor-specific files, like Khalid.md.
So the big LLM players are all in.
Absolutely. And beyond these tech giants, Factory.ai has been an incredibly active member of the working group, contributing significantly to the draft specification and committing to providing first-class support across all their products. Cursor, an innovative AI-native code editor, also brought its crucial support, effectively bringing the gap between sophisticated agentic backends and the developer's primary interactive interface. Furthermore, the ecosystem of support extends even wider to include other influential tools and platforms such as Aider, KiloCode, OpenCode, and the cutting-edge Z editor, all enthusiastically embracing the standard. This wide-ranging and rapid support from across the industry ensures that developers can adopt AGENTS.md with profound confidence, knowing it will be compatible with a diverse and ever-growing set of current and future AI coding tools, rather than being locked into the capabilities or limitations of a single vendor. It's a testament to a shared vision for an open, interoperable future.
The timeline for this convergence is quite extraordinary, frankly. It shows just how acute and urgent the need for this standard truly was. From widespread frustration to achieving industry consensus in a matter of weeks, that's lightning fast for establishing a new technical standard.
It truly is a remarkable timeline, and the sheer speed of convergence for Agents.md serves as an incredibly strong indicator of just how acutely the industry, from individual developers to major corporations, felt the pain of fragmentation. Community discussions from as recent as mid-2025 were absolutely teeming with developers expressing significant and mounting frustration with the chaotic and unsustainable landscape of proprietary instruction files. This grassroots pressure and shared pain rapidly galvanized into a collaborative standardization effort among the major tool providers. What's truly astonishing is that within a matter of mere weeks, not months or years, by July 2025, OpenAI had already acquired the dedicated Agents.md domain. And crucially, key players like Google and Anthropic had publicly committed to supporting the unified standard. This rapid transition from widespread, vocal frustration to an industry-wide consensus and a concrete commitment to a solution is a powerful testament to the standard's perceived immediate value and the collective, urgent desire for true interoperability within the rapidly expanding AI-assisted development space. It unequivocally shows that the industry was not only ready, but eagerly waiting for such a comprehensive and collaborative solution.
Wow, that's fast. So if you're a team lead or a developer with existing AI instructions already in place, perhaps using an older agent.md or a claude.md file, how do you make the switch to this new unified standard without causing disruption, breaking everything, and bringing your precious workflows to a grinding halt?
That's a crucial and very practical question, and thankfully the standard developers anticipated this challenge. They've provided a clear, practical, non-disruptive, and importantly, backward-compatible path for migration. The recommended strategy is actually quite elegant and simple to implement. First, you would simply rename your primary instruction file to align with the new standard. For example, if you currently have an agent.md or a claude.md, you would execute a command like mvagent.md agents.md or mvclaude.md agents.md to update its name to the new canonical standard.
Okay, step one, rename the file.
Simple enough. Second, and this is where the genius of backward compatibility really shines, you should create a symbolic link. You'd typically accomplish this with a command such as ln-agents.md agent.md. This clever step ensures that any older tools or agents in your pipeline that haven't yet been updated to explicitly recognize or search for the new agents.md standard will still be able to find and read the instructions by following the symbolic link. This critical measure allows your existing legacy workflows to continue functioning without any interruption during the transition period, providing a smooth and phased migration path.
Ah, the symlink trick. So old tools keep working. That's smart.
Very smart. Beyond this general migration strategy, the standard also provides guidance for configuring specific, popular tools to ensure they seamlessly integrate with Agents.md. For instance, users of the widely adopted AI agent Aider can easily configure it to read the new file by simply adding read agents.md to their.aider.conf.iml configuration file. Similarly, the Gemini CLI can be explicitly configured to use agents.md as its primary context file, ensuring it's always working with the latest standardized instructions. This structured, thoughtful approach to migration ensures a smooth transition for existing users and highlights the standard's deep commitment to real-world usability and developer experience.
To truly grasp the widespread commitment and the ecosystem's embrace of Agents.md, let's summarize who's doing what across the industry. Table 3 in our sources is perfect for giving us that comprehensive snapshot.
Right, if we connect this to the bigger picture, Table 3 offers an incredibly clear and compelling snapshot of the widespread commitment across the entire AI developer ecosystem. You see OpenAI Codex prominently listed as the originator and steward, providing full support, which is critical for foundational stability. Google Gemini CLI and Anthropic are identified as key collaborators, also providing or committed to full support, which is absolutely vital for ensuring broad cross-vendor adoption and establishing it as an industry-wide norm rather than a proprietary solution. Then, Factory.ai is listed as a key collaborator and active working group member with full support, indicating their deep involvement in shaping and implementing the standard. And importantly, a growing list of early adopters and influential tools like Cursor, Aider, Zed, and OpenCode all show supported status, meaning they've integrated Agents.md into their platforms. This comprehensive matrix really underscores the collaborative spirit and the significant diverse industry backing that Agents.md enjoys, demonstrating unequivocally that it's a widely embraced rather than a niche standard. It's a collective declaration that this is the path forward.
Standards often truly shine when they demonstrate their ability to handle complexity gracefully. How does Agents.md scale for those massive, sprawling, multi-package monorepos that are so incredibly common in enterprise development today? That's where many standards often struggle.
This is precisely where the elegance and foresight of Agents.md truly comes into its own, especially when dealing with the inherent complexities of modern monorepos. The standard provides an incredibly effective and scalable solution through the clever use of nested Agents.md files. While you absolutely can and should have a single Agents.md file at the root of your repository providing global, project-wide instructions applicable to the entire codebase, individual packages, applications, or sub-projects within that larger monorepo can also have their own more specific Agents.md files. This allows for highly tailored granular instructions precisely where they're needed.
So you can have multiple Agents.md files.
Yes, exactly. The standard specifies a clear and logical precedence rule. An AI agent, when given a task within a specific part of the codebase, should first read the nearest agent ss.md file it finds in the directory tree, moving upwards from its current working directory. This hierarchical mechanism is incredibly powerful. It allows for highly tailored, context-specific instructions, preventing unnecessary information overload for the agent. For example, general guidelines might live at the root, while highly specific build or test commands for a particular microservice reside only in that service's directory. This ensures the agent receives the most relevant and precise guidance for its immediate task.
Okay, so it looks for the closest one first. That makes sense.
It does. Let me give you some concrete examples to illustrate this. A root-level Agents.md might define crucial project-wide conventions, such as the overall commit message formats or high-level build commands relevant to the entire monorepo. Then, a file located at app's front-end Agents.md could provide highly specific instructions just for that particular front-end application, such as commands for running its development server, executing its unique browser-based end-to-end tests using Playwright, or specific deployment steps. Meanwhile, a file at package-tootle's Agents.md might detail a much simpler testing process, perhaps involving only basic unit tests with vdist, which are specific to that utility package. When an AI agent is tasked with modifying a component deep within the front-end application, it would intelligently prioritize and read the instructions from app's front-end Agents.md, knowing these are the most relevant and specific, and they would take precedence over the more general root-level file. This hierarchical, context-aware approach allows the standard to scale remarkably effectively, providing granular, precise control and bespoke operational playbooks in even the most complex and deeply nested code bases. It's an intriguing detail that the main OpenAI repository, a truly massive project itself, is cited as a large-scale example of this principle in practice, reportedly containing a staggering 88 separate Agents.md files at one point to manage its myriad subprojects. This demonstrates the standard's robust capability for real-world enterprise use.
88 files, wow. That's a truly elegant solution for monorepos. But it raises an important question. While simplicity is a profound strength, as we've discussed, has there been any debate or discussion within the community about its scalability for extremely large projects, particularly in light of just how much information those nested files might eventually contain?
Absolutely. This is not just a natural but a highly productive discussion for any maturing standard, as it faces broader adoption and more rigorous use cases. While the single.md file approach, or single file per subproject, offers clear advantages for simplicity and rapid initial adoption, some members of the developer community, particularly on platforms like Hacker News, have indeed raised insightful questions about its long-term scalability for extremely large and exceptionally complex projects. They've proposed an alternative or supplementary approach, utilizing a dedicated directory-based structure, something like .agents, instead of a single, potentially monolithic Agents.md file.
.agents directory. Interesting. What's the argument for that?
Well, the arguments for a directory-based structure are deeply rooted in principles of modularity and, crucially, token optimization for large language models. In this proposed model, the .agents directory would typically contain an index.md as the main entry point, but then allow for other specialized Markdown files dedicated to different concerns, such as auth.md for authentication-related instructions, testing.md for comprehensive testing guidelines, or performance.md for optimization directives.
Okay, so breaking it down into smaller topic-specific files.
Exactly. The potential benefits of this approach are compelling and twofold. First, it offers improved organization and human maintainability. For projects that genuinely require extensive and incredibly detailed instructions, perhaps dozens or even hundreds of pages of operational context, breaking them down into multiple logically grouped topic-specific files could be significantly easier for human developers to maintain, navigate, and keep up to date than managing one colossal monolithic agents.md file. This is simply better information architecture. Second, and perhaps even more importantly for AI interactions, it could lead to significant token optimization and enhanced accuracy. A truly sophisticated AI agent, operating within this directory structure, could be intelligently instructed to load only the context relevant to its current specific task. For example, if it's tasked with fixing a bug in the project's authentication system, it would only need to load the contents of .agentself.md. This focused approach would drastically reduce the number of tokens, those fundamental units of text, that an AI model processes sent to the underlying large language model, LLM. This not only has the potential to lower computational costs, but more importantly, it significantly reduces noise in the prompt by providing a much more focused and precise context. A more targeted context invariably leads to more accurate, relevant, and ultimately higher quality responses from the agent, dramatically improving its overall effectiveness and reducing instances of hallucination.
That's a fascinating debate, touching on both human usability and the very technical nuances of LLM interaction. What does this kind of discussion tell us about the standard itself? Is it a fundamental flaw, or is it a sign of something else entirely?
This debate, when we consider its broader implications, is absolutely not indicative of a flaw in the current standard. Instead, it's a perfectly natural, healthy, and incredibly productive discussion that invariably arises as a successful technical standard is adopted more widely, matures, and begins to be applied to the most complex and demanding edge cases. The current single file, or single file per subproject, approach of agents.md provides an extremely low-friction entry point that serves the vast majority of projects exceptionally well, driving its rapid initial success. The community discussion, however, points clearly toward a potential future evolution of the standard, perhaps a V2 or an optional, more structured, directory-based format designed specifically for truly enterprise-scale monorepos. This more advanced format could gracefully coexist alongside the simple default, providing a clear and well-defined scaling path for the most demanding users. This inherent tension between striving for elegant simplicity for broad adoption and the need for robust complexity for advanced use cases is a hallmark of any maturing and actively engaged technical community. It signals a vibrant, healthy, and continuously evolving standard, not one that is stagnating.
So after this deep dive, what does this all mean for the bigger picture? Beyond just making individual developers' lives a bit easier, what are the profound strategic implications of AGENTS.md for the entire AI tooling ecosystem and the future of software development itself?
The most profound and transformative impact of agents.md is that it acts as a powerful commoditizing force on the agent instruction layer. Before this standard, each AI tool vendor could create and control its own proprietary configuration format for instructing agents. This essentially allowed them to build a digital moat around their product, making it incredibly difficult and costly for users to switch to a competitor, fostering a subtle yet very powerful form of vendor lock-in. It was a competitive advantage based not on superior AI, but on proprietary documentation.
Right, lock in through file formats.
Exactly. By establishing a common, open, and universally accessible standard, AGENTS.md effectively neutralizes this proprietary competitive advantage. It fundamentally changes the game by ensuring that the ability to read and understand project instructions is now a baseline expected feature for all AI coding tools, rather than a unique differentiator. This has several incredibly positive and far-reaching consequences for the entire ecosystem. First, it creates a significantly lowered barrier to entry for new tools and innovators. A new startup, an academic research project, or an open-source community can now develop an AI coding agent that supports AGENTS.md from its very inception, allowing it to be immediately compatible with the thousands of projects that have already adopted the standard. A figure that, according to our sources, already exceeds 20,000 projects globally. This fuels rapid experimentation and broadens the field of players.
Makes it easier for new tools to compete.
Definitely. Second, and directly stemming from this, it leads to increased competition and profound innovation. With the foundational instruction layer standardized and commoditized, AI agent vendors are now compelled to compete and differentiate themselves on much more meaningful and impactful axes. This means they must focus intensely on the quality of their underlying large language models, the sophistication of their reasoning and planning capabilities, the raw speed of their execution, and how seamlessly they integrate into existing developer workflows. This fosters a healthier, more competitive market where innovation is truly driven by superior AI capability and developer experience, ultimately benefiting the end user with better, more specialized, and more powerful tools. And third, it brings about vastly enhanced interoperability. The standard fundamentally paves the way for truly advanced, multi-agent workflows, where developers can confidently chain together the absolute best tools for specific subtasks, one for refactoring, one for security, one for testing, all confident that each agent is operating from the same single source of truth regarding the project's operational context. This opens up entirely new paradigms for collaborative AI development.
That's a powerful vision for a more open and innovative future. Looking ahead, how do you see AGENTS.md evolving from here? Will it remain this elegant Markdown file, or are there even bigger plans, more formal structures, or integrations on the horizon?
As the Agent.md standard matures and deepens its roots within the development community, its evolution is likely to follow a path we've seen with other highly successful open standards in the software development world. We can anticipate several key developments that will solidify its role. Firstly, there will likely be a significant move towards formalization and robust governance. While it's currently an informal standard, skillfully stewarded by a coalition of leading companies, Agents.md may eventually transition towards a more formal, officially ratified specification under the governance of a neutral, nonprofit entity, perhaps something akin to the Linux Foundation or a similar open-source body. This move would ensure its long-term stability, reinforce its vendor neutrality, and establish a transparent, community-driven process for its future evolution, providing an even more solid institutional backing.
So maybe becoming more official, like other web standards.
Potentially, yes. Secondly, the tooling and validation ecosystem surrounding the standard is poised for significant and rapid growth. We're highly likely to see the emergence of a rich suite of complementary tools. Sophisticated linters to enforce best practices within Agents.md files, robust validators to check for correctness and strict adherence to the standard, and interactive generators to help developers quickly scaffold new files and automatically populate common sections. Factory.ai has already announced its intention to provide a validator, signaling the very beginning of this trend, which will further streamline adoption, improve quality, and make managing these files even easier.
More tools to make using it easier.
Thirdly, there's enormous potential for integration with other emerging standards. The AI development landscape is incredibly dynamic, with various other standardization efforts underway. There's a clear and exciting potential for future interplay between Agents.md and complementary protocols like the Model Context Protocol, MCP, or LMSTST.org, both of which aim to standardize how AI models interact with broader data and context beyond just project mechanics. Imagine a future where these standards work in concert, creating an even more seamless and powerful AI-native development environment, allowing agents to access and understand not just the project's operational mechanics, but also its broader data, dependencies, and business context without ambiguity. This would unlock truly intelligent, context-aware AI collaboration.
Interesting, connecting the dots with other standards.
And finally, directly related to our earlier discussion about scalability, we can certainly expect a continued evolution of the format itself. The community debate around a directory-based structure for extremely complex projects suggests a highly likely evolutionary path. The standard may evolve to officially support a more structured, perhaps directory-based format as an optional alternative to the simple single-file approach. This will provide a clear and elegant scaling path specifically for enterprise users and the largest, most intricate code bases, allowing for greater modularity and more precise context optimization without sacrificing the initial simplicity and low friction that have driven its initial widespread success. This thoughtful expansion will ensure Agents.md remains relevant and powerful across the entire spectrum of project complexity.
To wrap up this fascinating deep dive, how would you summarize the pivotal, defining role of Agents.md in this rapidly evolving landscape of AI-assisted software engineering? What's its lasting impact?
Agents.md stands as a truly pivotal development, marking an unambiguous transition from what was once a fragmented, experimental, and often chaotic phase in AI-assisted development to a much more mature, interoperable, and standardized ecosystem. It represents the definitive step in formally recognizing AI agents not merely as sophisticated tools, but as first-class, essential participants in the modern software development lifecycle. It provides that universal onboarding document, the shared playbook for our AI teammates, giving them the clear, structured, and predictable channel for communicating essential, non-code context that they absolutely need to collaborate effectively, reliably, and safely with their human counterparts. Its incredibly rapid industry-wide adoption is a loud and clear signal of its immense value and profound necessity. The standard brilliantly resolves immediate developer pain points, those cursed setups and maintenance burdens, while simultaneously laying the essential groundwork for a future dominated by more sophisticated, truly multi-agent development paradigms. As the capabilities of AI agents continue to advance at an astonishing pace, the foundational role of AGENTS.md will only become more critical, making it an indispensable and enduring component of the modern software development toolchain, truly shaping how we build the future. #outro.
What an incredible deep dive into AGENTS.md. From the initial chaos of proprietary conflicting files to the emergence of a unified open standard that's fundamentally changing how AI collaborates with developers. It's truly a testament to industry collaboration, shared vision, and the power of a simple, effective idea.
And for you, the learner, understanding agents.md isn't just about familiarizing yourself with a new file in a repository. It's about grasping a fundamental, paradigm-shifting change in how we manage complex software projects with AI, making your work more efficient, your projects more consistent, and opening doors to capabilities we're only just beginning to imagine in terms of truly intelligent software development. It's a foundational piece for the future of coding, and knowing it gives you a crucial advantage.
So what does this all mean for us? As AI agents become even more sophisticated, with AGENTS.md serving as their shared universal instruction manual, how will this empower us as developers to orchestrate a truly intelligent orchestra of specialized AI assistants? How will this partnership change not just how we code, but what kinds of software we can build, and at what unprecedented speed? That's a truly powerful thought to consider, isn't it? We hope this deep dive has given you a crystal clear understanding of AGENTS.md and its profound implications for the future of software engineering. Until next time, keep exploring, keep building, and keep pushing the boundaries of what's possible.